All right, let's get right into it. Today, we are breaking down a story that honestly feels like it's straight out of a movie. It's called CodeBreach, and it was a critical security flaw that put Amazon Web Services and, let's be real, a huge chunk of the internet in some serious danger.
And I'm not being dramatic here. The security researchers at Wiz, the ones who actually found this thing, they put it bluntly. This was a threat to every single AWS account. I mean, the stakes just don't get any higher than that.
And this is the absolute mystery at the heart of the whole story. It all came down to a tiny, almost impossible-to-spot mistake, just 2 characters missing from a line of code. So how on earth is that even possible? Well, that is exactly what we're going to unpack. To really get what happened, we have to go to the scene of the crime. And in the software world, that scene is almost always the CI/CD pipeline. You can think of it as the automated assembly line, where all the code gets built, tested, and shipped out. A really big part of that process is something called continuous integration, or CI for short. So imagine this. Every single time a developer wants to add new code, they send in what's called a pull request. The CI system then automatically snags that code, builds it, and runs a bunch of tests to make sure nothing's broken. It's all about moving fast. But you can probably see the problem, right? This automation creates a huge security headache, especially for open source projects where anyone can contribute. If some stranger can submit code, what's stopping them from hiding a virus or a backdoor in their pull request? If your system just automatically runs it, you might be handing an attacker the keys to the kingdom. Now, of course, AWS knew all about this risk. They had a system called CodeBuild, and it was specifically designed with a security filter to stop this exact kind of attack from happening. And, from the outside looking in, it looked completely secure. So the Wiz researchers started digging, and they focused on these 4 major AWS projects. They're all important for sure, but the real prize, the crown jewel, is that first one, the AWS JavaScript SDK. It is a fundamental building block for countless apps, including, and this is important, AWS's own management console. So here's how the defense was supposed to work. It was an actor ID filter. The idea was simple. It's an allow list. Only pull requests from GitHub users with specific pre-approved IDs, trusted AWS developers, would be allowed to trigger a build. Sounds pretty solid, right? Well, it wasn't. And this is the aha moment. This is where the researchers found that tiny, subtle flaw that completely unraveled the whole system. Okay, so check this out. The clue was that little vertical bar between the numbers. The researchers noticed the IDs weren't separated by commas, but by these pipe characters. And that one little detail changed everything. It meant the system wasn't checking against a simple list, it was using a regular expression, a super powerful way to match text patterns. And this particular pattern had a fatal flaw. This slide just lays it out perfectly. What AWS wanted was a simple check. Does the user's ID exactly match one of the numbers on the list? But the code was missing those 2 critical characters, the anchors that act like bookends, telling the system the pattern must start here and end here, and that's it. Without them, the code only checked if a user's ID contained a trusted number anywhere inside it, a world of difference. And hey, if you think this is some kind of obscure 1 in a million mistake, it's really not. As this commenter on Hacker News points out, security pros are constantly having to fix this exact kind of regex error. It's a common, incredibly frustrating problem. So, once the researchers found the vulnerability, they came up with this absolutely genius plan to exploit it. They needed to create a brand new GitHub account that had a user ID containing one of those trusted shorter IDs. They gave the mission a cool name, Catching a GitHub Eclipse. So here's the trick. GitHub user IDs are just sequential numbers. A few years ago they were 5 digits, now they're up to 9. The researchers did the math and figured out that with so many people signing up, a new 9-digit ID that just happened to have a trusted 6-digit ID embedded inside it would pop up roughly every 5 days. So basically, they had to win a race against the entire internet. Here's how they did it. First, they predicted the precise moment their target ID would become available. Second, they got around GitHub's bot detection by preparing hundreds of automated accounts using a special developer workflow. Third, at exactly the right second, they unleashed a massive registration flood. And finally, they got it. Boom! There it is. User ID 226755743. You can see it right there. It contains the trusted ID 755743. This was their golden ticket. This was the ID that would fool that flawed filter and let them waltz right into AWS's secure system.
So they had their malicious user ID. They were in. What was the verdict? What kind of damage could an attacker actually do with this?
Well, they submitted a pull request from their special bot account. The filter let it through, no questions asked, and it triggered a build. The code they submitted then ran inside that secure environment, and it was able to dump secret GitHub credentials right out of the system's memory. Just like that, they had full admin access, a complete takeover of the AWS JavaScript SDK.
And the potential fallout, the blast radius, it was just staggering. According to Wiz's research, that one piece of software, that one SDK, is used in a whopping 66% of all cloud environments. Let that sink in. 2 out of every 3 cloud deployments could have been compromised.
But here's the real kicker. One of the biggest users of that SDK is the AWS Console itself, the website that millions of us use to manage our cloud stuff. A malicious update to the SDK could have turned the console into a weapon, stealing credentials and potentially compromising every single AWS user on the planet. Now, thankfully, these were the good guys. They immediately reported the flaw to AWS, who, to their credit, responded incredibly fast. The main issue is patched in just 48 hours. This is exactly how responsible disclosure is supposed to work. So what do we all learn from this? How can you stop this from happening to you? Well, the experts have 4 key recommendations. First, always anchor your regular expressions. Use those bookends. Second, make a human-approved builds from new contributors. Third, don't use the same powerful key for multiple projects. And finally, always use the least amount of privilege necessary. And that really just leaves us with one final thought. CodeBreach was caused by just 2 missing characters in one line of code. It just makes you wonder, doesn't it? In all the incredibly complex digital systems we all rely on every single day, what other tiny, overlooked flaws are just sitting there, waiting to be found?